So the fifth output that I want, this is called a validation measure, and this is kind of a measure I might put in my model after my results didn't really make sense, and I'm trying to figure out what's going on with my model. But for the sake of demonstration here, I'm also going to put it in this model, even though I haven't really looked at results and haven't really determined that there could be a problem.
Is this a circle interference measure also?
Yes, it's going to be a circle interference measure.
So sorry I said that a little quietly because I wasn't sure what I was going to say. But so we're still using a circle interference measure, and then this kind of is going to answer your question, is if you're using a circle interference measure on a whole pin that is used in a move with a float, if your default setting, which our moves usually default to, constant, meaning the hole's going to be at the edge of the pin all the time, this result should output a 0. There's never any clearance.
Yes, exactly.
So now I will let him finish what he was going to say. I probably said what he's about to say.
That's pretty much it. That's basically what we're going to do. Based on how I have my step plane move set up, I've got these, 2 little arrows here that are representing that I don't want this pin to leave the perimeter of this hole. And with how I have my float set up, because I have default float, it means that I always have contacts between my pin and my hole. So based on what I know the circle interference measure gives out, if my move is moving as I think it is, then I should get no variation between my pin and my hole, because my pin is always touching my hole, or so my step plane move is programmed to do. Now, if these 2 directions aren't exactly right, or maybe I accidentally have my right-hand panel or left-hand panel in a move down the line and didn't really realize that I had it as an additional move part, then that move would have been overwritten, and then I could try and start to hunt down why this isn't doing what I think it's doing. This would be the first step that I do to just, kind of doing a sanity check to make sure that everything is lining up the way I think it should. So whereas last time for the circle interference measure, I had a list of objects and a list of targets, and I was just trying to check how often are all these going to fit. In this case, I'm just going to isolate this problem. I'm only going to check a single pin. I'm only going to check a single hole. And I know exactly how my output should look. The moment I start deviating, I should always see 0 show up in this current number down here. And if I actually ran my analysis, I should come back with a, sharp spike at the very least that shows me that I have no variation between this pin and this hole, because they're always touching each other. So let's go to our model and see how that looks. So I'm checking out this spot right here. Let me go ahead and get oriented correctly.
I don't know how to get a normal view in Creo.
I'll teach you sometime. It's for another webinar.
Right.
So if I go ahead and I nominal build, and then I select deviate, so currently my platform and my thing are moving, so it's a little bit harder to see. But those of you with sharp eyesight should be able to tell that that pin is always staying within the boundaries of that blue hole. So it looks like it's doing what I think it's doing, but let's just, we added this validation measure, so let's just make sure. If I hit nominal build and hit current, I get 0.25 millimeters of clearance. I got an M6 bolt going into a 6.5 millimeter hole. So looks like it's working correctly. And if I hit deviate, see that start moving around, and if I hit current ever, this number should never leave 0, or -0, I suppose, but it's always right there at 0.
What's the difference between -0 and 0? I'm just messing.
It's a question for another webinar.
That's for the Zen at the top of the hill.
Exactly.
That tells you what the value is past the 6 decimal places that are displayed.
Okay. So it's -0 point, and then like 17 zeros, and then 1, and like that's why it's coming up negative.
Exactly.
Okay.
Might even be able to see it if you hit summary.
Might.
Not that you wanted to go that deep, but
I wanted to leave it for the Zen at the top of the hill.
So now, what a validation measure looks like if you actually run your analysis, we just kind of validated it through, visual validation, then also hitting the current button a bunch. It seems to be working, But if you actually wanted to run your analysis and then go to that measure to see what it should look like, and after this analysis finishes, I'm just going to jump right to that measure. So give it a second here. So we got a few different measures here, but if I jump right to that validation measure, we'll see I don't have a distribution. All of my specimens are coming in between, 0 and 0.
Between 0
I
and
have
0.
a mean of 0 and a 6 sigma value of 0. So it seems like this validates to me that that pin is staying within that hole. So that's all that we're talking about when we talk about validation measures. So all right, that's validation measures. We got a couple more to go, and I think we're gonna be good on time here.